Hello, students. This is Mrs. Buelson, and we are having a remote lecture today. So make sure you are on page 43 of your lecture notes for Newton's second law. Page 43. This first slide is the bottom left slide on page 43. We're now talking about free fall. So first, a review of free fall, of course. So free fall is the acceleration due to gravity on Earth when there is nothing but the pull of gravity acting on an object. The greater the mass of the object, the greater its force of attraction towards the Earth. The smaller its tendency to move, the greater its inertia. So acceleration of two bricks is the same because the twice as massive brick also experiences twice the pull of gravity. The acceleration of both sets of bricks is the same. All things in free fall accelerate at the same rate of about 10 meters per second squared. Please fill in the blanks for this slide. Now we'll check our understanding. Bottom right slide of page 43. So at one instant, an object in free fall has a speed of 40 meters per second. What is the object's speed 1 second later? Think about this for a moment and decide on your answer. The correct answer is that 1 second later, if an object is in free fall, its speed will be 50 meters per second. This assumes that the object is falling in the downward direction, where it's speeding up as it falls. If it were moving in the upward direction, it would be slowing down as it goes, and its speed would be 30 meters per second. Now we're on page 44, top left slide. A 5 kilogram iron ball and a 10 kilogram iron ball are dropped from rest. For negligible air resistance, that means we ignore air resistance, what will the acceleration of the heavier ball be compared to the light? Will it be the same, less than, more than, or undetermined? Think about your answer. Both iron balls, 5 kilogram and 10 kilogram, in free fall, ignoring air resistance, will have the same acceleration. Force over mass gives us the same acceleration of 10 meters per second squared in either case. Last question for free fall. A 5 kilogram and a 10 kilogram object or ball are dropped from rest. When the free-falling 5 kilogram ball reaches 10 meters per second, what is the speed of the free-falling 10 kilogram ball? They're both dropped from rest at the same time. The word free fall means that we're ignoring air resistance. Free fall. Both objects are in free fall, so at the same time, they should be going the same speed. So this has been a review of free fall. Now let's consider what happens in real life, in reality, when air resistance plays a role. Air resistance is a form of friction, and it's the friction of the air, which is a fluid, passing an object that's falling. When an object falls downward through the air, it experiences the pull of gravity, pulling downward, and in this diagram that's noted as mg. We remember that weight or pull of gravity is mg. It also experiences a drag force acting upward. Air resistance is commonly also called drag. So we have downward gravity and upward drag. In non-free fall, the condition of not free fall is that air resistance cannot be ignored. It is not ignorable. I don't think this is actually a word, but it's not ignorable. Air resistance depends on two things. It depends on the speed of the object and the frontal surface area. That just means the area that's presented at first to the air. So how fast and essentially how wide an object is. When an object is moving fast enough so that the air resistance builds up to be big enough to equal the force of gravity, at that point, the pull of gravity in the downward direction is equal to the air resistance pushing back up on the object. It's now in dynamic equilibrium. These two forces are equal in magnitude and opposite in direction. So no net force means it's not accelerating. If it's not accelerating, its velocity does not change, right? So it's in dynamic equilibrium, it's moving, it's falling, but it's no longer accelerating. So we call this time terminal speed, or we call this occurrence terminal speed. Terminal speed is the term for the occurrence when acceleration terminates. The acceleration ceases, air resistance is equal to weight. Net force is 0, and the object is in dynamic equilibrium. An example of non-free fall would be a skydiver jumping from a plane. A skydiver in fall, after jumping from a plane, the two forces acting on the skydiver are weight and air resistance. As that skydiver falls and the speed increases, the air resistance on the skydiver also increases, and the net force on the skydiver decreases. As that net force decreases, the acceleration also decreases, according to Newton's second law. When acceleration is when air resistance is equal to the diver's weight, the net force on the skydiver is 0 and acceleration terminates. So this doesn't mean that the skydiver stops moving. It means that the skydiver stops speeding up. The diver is at terminal velocity and continues from that point at constant speed. This is the bottom right slide on page 45. When a 20 Newton object encounters 5 newtons of air resistance, what is its acceleration? When an object encounters any measurable amount of air resistance, you must conclude that the acceleration is less than 1g. 1g refers to 1 times 10 meters per second squared. So less than 1g of acceleration. Now we're turning the page to 46. One more question example. Actually, we have a few more question examples. A 50 Newton person is falling at terminal speed. How much air resistance does that 50 Newton person need to have to be at terminal speed? If a 50 Newton person is falling at terminal velocity, the net force on that 50 Newton person must be 0. So the downward pull of gravity of 50 newtons must be countered by 50 newtons of air resistance. 50 minus 50 is 0. Now we imagine a skydiver falling faster and faster through the air. What happens to air resistance as this diver goes faster and faster? Air resistance increases as the speed of an object increases. So as the skydiver falls and goes faster and faster, the air resistance increases. The skydiver is falling, going faster and faster through the air. What happens to the net force? Air resistance increases. The net force on the skydiver is the weight of the skydiver minus air resistance. So the net force actually decreases as air resistance increases.